The universe did not announce itself with light. It whispered through absence. When we look out into the night sky, what we see is only a fraction of what is truly there. Stars burn, galaxies glow, but their motions betray a deeper secret. They spin too fast. They cling together too tightly, as if held by an invisible hand. For decades, astronomers searched for the missing weight behind the cosmos, something unseen, untouchable, yet unmistakably real. They called it dark matter, not because it is evil, not because it is empty, but because it refuses to be seen. It shapes galaxies without touching them. It sculpts the universe while remaining silent. This is not just a technical problem. It is a philosophical wound. Most of reality does not speak to our instruments, our eyes, or our senses. We live inside a universe whose dominant substance hides in plain existence, and that raises a quieter, more unsettling thought. What if the darkness is not nothing at all? What if it is something else entirely? Moving beside us, unseen, elsewhere? For centuries, gravity was our most trusted guide. It was the quiet law that never failed us, the invisible thread that stitched the heavens together with perfect obedience. From falling apples to wandering planets, it behaved with a reliability that felt almost comforting. The universe, we believed, followed rules. And gravity was the rule that never lied. Then we looked farther. When astronomers first began mapping entire galaxies, not as points of light, but as rotating systems, something subtle felt off. At the bright centers, where stars were packed tightly together, gravity behaved exactly as expected. The math held. The equations sang. But at the outskirts, where stars thinned and light grew sparse, the harmony broke. Those outer stars were moving too fast. According to everything we knew, they should have been flung into the void, torn away by their own momentum. The visible matter simply wasn't enough to hold them, and yet they remained, bound, loyal to their galactic homes, as if something unseen was gripping them, refusing to let go. At first, the anomaly was easy to dismiss. A measurement error, a calibration issue, a missing decimal point. Science has learned, through hard experience, to distrust first surprises. Nature often appears strange only until the instruments improve, so astronomers recalibrated. They double-checked distances, brightness, mass estimates. They ran the numbers again. The numbers did not change. The galaxies kept spinning too fast. Over and over, the same result emerged, stubborn and unyielding. The outer stars obeyed a gravity that should not exist. And slowly, uncomfortably, confidence began to erode. But this was only the beginning. As telescopes grew more powerful, they stopped looking at single galaxies and began studying clusters, vast cities of galaxies bound together across millions of light years. Here, gravity was expected to be even more predictable. With so much visible mass, the collective pull should have been easy to calculate. It wasn't. Galaxy clusters were behaving as if they were far heavier than they appeared. Individual galaxies moved within them at impossible speeds, like sparks trapped inside an unseen furnace. And more disturbingly, these clusters acted as gravitational lenses, bending light from distant objects behind them. Light that should have passed straight through was curved, stretched, distorted into arcs and halos. Gravity was sculpting space itself, But when scientists added up all the visible matter, every star, every cloud of gas, every glowing structure, it accounted for only a fraction of the lensing observed. The universe was bending light with weight that was nowhere to be found. This was not a small discrepancy. It was not a rounding error. It was catastrophic. Something massive was present, and it refused to glow. At this point, the discomfort turned into something sharper. Gravity, the most reliable force we knew, was either misleading us or revealing a deeper truth we were not ready to face. Some scientists proposed radical solutions. Perhaps gravity itself changed behavior over vast distances. Perhaps Einstein's equations, so successful on solar scales, quietly failed across cosmic ones. Maybe the universe followed different rules in its grandest arenas, but every modification came with consequences. Fix one problem and another broke. Tweak gravity to explain galaxy rotation and clusters no longer worked. Adjust it for lensing and the early universe fell apart. The laws could be bent, but never without tearing somewhere else. The universe was cornering us. And then came the reluctant confession. What if gravity was not wrong at all? What if the equations were telling the truth, and we were the ones refusing to listen? What if the missing mass was not missing, but invisible? The idea was unsettling in its simplicity. An entire form of matter that does not emit light, does not absorb it, does not reflect it. Matter that passes through space and through us, almost without a trace. Dark matter. The name itself felt like an admission of ignorance. Not a solution, but a placeholder. A label for something real that refused to be seen. It interacted through gravity alone, tugging on stars, shaping galaxies, anchoring clusters, while remaining completely silent to every other force we knew how to measure. Once spoken, the idea could not be unsaid. Because when scientists rewound the universe in their simulations, dark matter did something remarkable. It made everything else make sense. The early universe, once a chaotic fog of particles, began to form structure. Tiny fluctuations grew into filaments. Filaments collapsed into galaxies. Galaxies assembled into clusters. Without dark matter, the universe should have remained smooth, featureless, too calm to create complexity. But it didn't. Something cold and unseen had acted as scaffolding for reality itself, long before the first stars ever ignited. Ordinary matter, the kind that forms planets and people, seemed almost secondary, drawn into shapes dictated by an invisible framework laid down in silence. This realization carried a quiet terror. Everything we see, every shining galaxy, every nebula, every cosmic landmark, appeared to be decoration on a hidden structure. We were not living in the main architecture of the universe. We were living in the visible residue. And still, skepticism remained. Science demands proof, not poetry. If dark matter existed, where was it now? Why had no detector ever captured it? Why did it pass through Earth, through laboratories, through human bodies, without a whisper? Experiments were built deep underground, shielded from cosmic noise. Sensitive instruments waited patiently for collisions that never came. Year after year, silence answered back. And yet, the cosmos refused to let go of the idea. Every new observation tightened the net. The cosmic microwave background, the ancient afterglow of the Big Bang, contained subtle patterns that only dark matter could explain. Large-scale surveys revealed the same invisible filaments everywhere we looked. The universe kept insisting on its presence. We found ourselves in a strange position. Trusting gravity meant accepting something we could not see. Rejecting it meant dismantling the most successful physical theories ever written. Either choice demanded humility. This was not discovery through triumph. It was discovery through surrender. Dark matter did not announce itself with fireworks or equations carved in stone. It emerged as a consequence, a shadow cast by consistency, a confession forced out by mathematics when every other explanation failed, and the deeper implication lingered, unspoken but heavy. If most of the universe is invisible, what else have we mistaken for absence? If gravity can reveal realities our senses cannot touch, how incomplete is our picture of existence? We measure what shines, but live inside what does not. The universe did not break its laws. It expanded them, and in doing so, it reminded us of a sobering truth. Either gravity is broken, or reality is incomplete. Long before the first star burned its way into existence, the universe was already building a framework, not with light, not with fire, but with something colder, quieter, and infinitely more patient. In the beginning, after the universe expanded from its first blinding instant, matter rushed outward in all directions, a turbulent sea of particles cooling as space itself stretched. For a moment, cosmically speaking, it was chaos. A nearly uniform fog, too smooth to create anything lasting, too calm to give birth to complexity. And yet, order emerged. Not because ordinary matter decided to clump together, but because something else moved first. Something unseen began to gather, slowly and relentlessly, responding only to gravity. Dark matter did not shine, did not collide, did not heat up or glow. It simply accumulated. Wherever it gathered, gravity deepened. Wherever gravity deepened, the universe began to bend toward structure. This was the universe's first architecture. As time passed, dark matter collapsed into vast, invisible filaments stretching across millions of light years. These filaments intersected at dense nodes, forming gravitational wells so deep that ordinary matter could not resist them. Gas flowed inward like mist drawn into valleys. Along these hidden highways, the universe learned how to organize itself. What we call the cosmic web was born. From our human perspective, the universe appears scattered, galaxies floating in darkness, separated by unfathomable distances. But zoom out far enough, and a pattern emerges. Not random, not chaotic. A delicate, sprawling lattice, where filaments connect clusters, and immense voids yawn between them like silent oceans. This structure was not sculpted by stars. It existed before stars were even possible. Light arrived late to the story. In simulations, when scientists remove dark matter, the universe fails. Galaxies never fully form. Matter disperses too evenly, too gently. Gravity alone, acting on visible material, is not enough to overcome the expansion of space. The universe remains smooth and empty, a place without anchors, without homes. But when dark matter is included, everything changes. Structure appears almost immediately. Tiny fluctuations in the early universe, imperceptible ripples in density, are amplified by dark matter's gravitational pull. Those ripples grow into filaments. Filaments collapse into halos. Halos become cradles where gas can cool, compress, and finally ignite into stars. Without dark matter, there are no galaxies. Without galaxies, there are no suns. Without suns, there are no planets. And without planets, there is no one left to ask why the universe exists at all. This realization carries a humbling weight. Every atom in your body was assembled inside a galaxy that formed because dark matter came first. The Milky Way itself is wrapped in an enormous halo of unseen mass, extending far beyond its visible stars. Our galaxy does not float freely in space. It is embedded in a gravitational cocoon we cannot see but cannot escape. We are living inside a shadow. The scale of this structure defies intuition. The cosmic web spans the observable universe, linking matter across distances so vast that light takes billions of years to cross them. The voids between filaments are some of the emptiest regions known, yet even they are shaped by the pull of invisible mass surrounding them. Nothing in the large-scale universe is accidental. Every absence, every cluster, every shape is a consequence of a hidden design. But design does not imply intention. It implies inevitability. Dark matter does not plan. It does not choose. It follows gravity with blind obedience, and in doing so, it becomes the silent architect of everything we recognize as structure. It does not care about stars, or life, or meaning. And yet, without it, meaning never gets a stage. This is the paradox that lingers beneath every observation. The universe feels luminous, alive with color and motion. But its true foundation is dark, cold, and indifferent. The things we see are latecomers, decorating a skeleton that was already in place long before light learned how to burn. And that skeleton is ancient. When we observe the cosmic microwave background, the faint afterglow of the universe's infancy, we see the earliest fingerprints of dark matter's influence. Subtle temperature variations reveal where mass had already begun to collect just a few 100,000 years after the Big Bang. At that time, the universe was still opaque. Light could not travel freely, and yet, structure was already forming. Dark matter was working in the dark. This shifts our perspective in a profound way. We often imagine the universe as something that began bright and became complex over time. But in truth, complexity was seeded by something invisible, something we still cannot touch. Light followed gravity, not the other way around. Visibility was not the cause of structure, it was the consequence. And this realization invites discomfort. If the universe's largest structures are shaped by something we cannot see, how much of reality is fundamentally inaccessible to our senses? We pride ourselves on observation, on evidence, on what can be measured and verified. But dark matter forces us to confront a quieter truth. Some of the most important things in existence never announce themselves. They simply act. The cosmic web does not reveal itself directly. We infer it by tracing where galaxies gather and where they do not. We map absence as carefully as presence. In doing so, we learn that emptiness itself has shape. Voids are not random gaps. They are regions carved out by gravity's invisible hand, places where matter was pulled elsewhere long ago. Even nothingness has a history. As this picture sharpens, confusion gives way to awe. The universe is not a scattered accident. It is a connected whole stitched together by forces that predate light, stars, and thought. What appears empty is structured. What appears random is guided. What appears visible is only the surface. And slowly, reverence replaces certainty. Because the more we understand this hidden framework, the smaller we feel within it. Humanity's story, every civilization, every triumph, every fear, unfolds on a single planet, orbiting a single star, inside a single galaxy, anchored to an invisible halo we barely comprehend. Our entire cosmic address exists because of something we cannot see, cannot touch, and still do not fully understand. We are not standing on solid ground. We are suspended in a vast gravitational tapestry, woven long before we arrived. This does not diminish us. It contextualizes us. It reminds us that familiarity is not fundamental, that what feels central to our experience, light, matter, solidity, is not the universe's foundation, but its ornamentation. The deeper reality operates quietly, patiently, without concern for recognition. Dark matter never needed to be known to do its work. And perhaps that is the most unsettling truth of all. The universe does not require observers to function. It builds itself regardless, following rules that remain true whether we understand them or not. Our awareness is a late addition, a flicker of consciousness riding atop a structure billions of years in the making. When we look out at the night sky, we see islands of light, but beneath them lies the cosmic skeleton, holding everything in place. An architecture without blueprints, a framework without witnesses. Everything familiar was built on something forever unseen. For a time, the mystery felt solvable. Once dark matter revealed itself through gravity, the next step seemed obvious. If it shaped galaxies, if it anchored the cosmic web, then it must be made of something. A particle, a constituent, a missing piece of the standard model waiting patiently to be found. And so the search turned inward. Beneath mountains and ice sheets, deep underground where cosmic radiation could not intrude, detectors were built and sealed into silence. Massive tanks of liquid xenon waited in the dark, colder than space itself. Crystals were cooled to near absolute zero, sensitive enough to feel the faintest whisper of impact. Every experiment was designed around the same quiet hope, that one day an invisible particle drifting through Earth would collide, however briefly, with ordinary matter. It never happened. For decades, physicists chased a leading candidate known as the WIMP, weakly interacting massive particle. Elegant, predictable, almost comforting. WIMPs fit neatly into existing theories and promised a universe that remained mathematically tidy. If they existed, they should be everywhere, passing through your body by the billions each second, unnoticed yet detectable with the right precision. The detectors waited. Year after year, the data returned empty. The graphs flattened. The anticipated signal never rose above the noise. Each new upgrade brought renewed optimism, followed by the same quiet disappointment. It was not failure in the dramatic sense. There were no explosions, no contradictions, no errors to fix. Just silence. And silence. repeated long enough, begins to speak. So the search widened. If not WIMPs, then actions, ultra-light particles born from theoretical necessity rather than observation, delicate, elusive, almost ghost-like. Experiments were redesigned, new methods invented. Entire collaborations devoted years to tuning instruments sensitive enough to detect a particle so subtle it barely existed at all. Again, nothing. The absence was not confined to underground labs. At the largest machines humanity has ever built, particles were smashed together at energies approaching the speed of light. The Large Hadron Collider tore matter apart, recreating conditions not seen since the early universe. If dark matter could be created, even briefly, this was where it should appear. But every collision told the same story. Known particles behaved as expected. Energy was conserved. The equations held. And dark matter remained missing. At first, patience dominated the mood. Science is slow by nature. Discoveries often take decades. The Higgs boson itself had once seemed unreachable, until suddenly it wasn't. Hope persisted, grounded in history and discipline. But as the years passed, optimism began to thin. Each null result did more than eliminate a possibility. It narrowed imagination. Entire classes of theories quietly died, not with drama, but with resignation. What had once seemed inevitable began to feel evasive. Dark matter was there in the cosmos, undeniable and overwhelming. Yet here on Earth, it behaved like a rumor that refused to materialize, and the question shifted. What if dark matter was not interacting because it could not interact? What if it belonged to a realm of physics fundamentally disconnected from ours? The more sensitive the detectors became, the more unsettling the silence grew. Absence, once tolerable, now felt deliberate. This was not ignorance. It was resistance. Physicists began to confront a disturbing possibility that dark matter might not be a single particle at all, or worse, that it might not be particle-like in any familiar sense. The assumption that everything real must be detectable through interaction began to wobble. Our tools are built on contact, on exchange, on forces meeting forces. But what if dark matter does not play by those rules? The history of physics is filled with moments where reality refused to fit expectation. Neutrinos passed through Earth unnoticed for decades before they were finally caught. Quarks were once considered mathematical tricks. Black holes were dismissed as curiosities. But in every case, persistence was rewarded with detection. Dark matter, so far, offered no such concession. This creates a unique kind of unease. Billions of dollars, thousands of scientists, entire careers devoted to a search that returns nothing but tighter constraints and shrinking possibilities. The universe continues to insist that dark matter exists, and yet, when asked directly, it refuses to answer. At some point, frustration becomes philosophical. What if we are making a category error? What if dark matter is not something to be caught, but something to be inferred? Forever? Gravity sees it, but nothing else does. Perhaps that is not a limitation of our technology, but a property of reality itself. We are used to progress meaning revelation, a signal, a spike in the data, a discovery headline. But here, progress looks like subtraction. like crossing out ideas one by one, watching the conceptual space collapse inward. The hunt continues, but its tone has changed. New proposals emerge. Hidden sectors, dark forces, entire shadow particle families that barely brush against our universe. These ideas stretch imagination and patience alike. They suggest that dark matter may live in a parallel framework of laws, one that overlaps with ours only through gravity. If true, then our experiments are not failing. They are irrelevant, and that thought is deeply unsettling, because it implies that some aspects of reality are not meant to be accessed directly, that the universe contains components which influence us profoundly, yet remain permanently beyond our reach. We can feel their weight, trace their outlines, and map their effects, but never touch the source. This challenges a core belief of science itself, that everything real can, in principle, be observed. Dark matter stands at the edge of that belief, testing it without mercy. It offers evidence without encounter, influence without interaction, presence without participation. Hope still exists, but it is quieter now, more cautious, no longer anchored to a single experiment or particle candidate. Instead, it drifts among possibilities, waiting for a conceptual shift rather than a technological breakthrough. And perhaps that is the deeper lesson unfolding here. The universe may not yield its secrets by force, smashing particles harder, digging deeper underground, building larger detectors. These may not be enough. Some truths might require us to rethink the questions themselves, because after decades of searching, one thing has become clear. The particle that was supposed to arrive never did. And in its absence, a more troubling question takes shape. Not about detectors or theories or funding cycles, but about perspective. What if we are searching in the wrong universe? At some point, persistence turns into humility. After decades of searching for a particle that never arrived, physics was forced to confront an unsettling possibility. What if dark matter is not hidden within our universe at all? What if it is not a substance we can isolate, collide, or trap? What if the problem is not that we have failed to detect it, but that we have misunderstood where it belongs? This is where the question bends inward and then outward at the same time, because gravity behaves differently from every other force we know. It is astonishingly weak, yet impossibly far-reaching. It refuses to be confined, shielded, or switched off. While electromagnetism binds atoms and light, while nuclear forces rule the cores of stars, gravity alone stretches across the entire cosmos, indifferent to distance, patient beyond time. It is the one interaction that seems to ignore boundaries, and that makes it suspicious. What if gravity is not fully contained within our universe? What if it is the only force that can cross a deeper divide, one we cannot see, touch, or even directly define? In this view, dark matter is not matter at all. It is gravity leaking in, a fingerprint of something massive that exists beside us, not within us. A shadow universe. The idea sounds radical, but it does not emerge from fantasy. It arises from the same place dark matter itself did: mathematical discomfort. The equations allow for more dimensions than the ones we experience. They do not forbid parallel sectors of reality. In fact, some of the most advanced theories in physics seem to expect them. In certain models, our universe is not the whole of existence, but a membrane, a brain, floating within a higher dimensional space. Everything we know, from particles to light to time itself, is trapped on this brain. Everything except gravity. Gravity, uniquely, can move between layers. If that is true, then massive structures in a neighboring universe could exert gravitational influence on ours without ever revealing themselves directly. Their stars would not shine for us. Their particles would never collide with ours. Their light would remain forever invisible, but their weight would be undeniable. This reframes dark matter in a startling way. The reason we cannot detect it is not because it is weak or elusive, but because it is not here. It belongs to another cosmic layer, overlapping our own, like two shadows cast by different fires. And suddenly, the silence in our detectors feels different. Not like failure, like distance. Other theories explore a related but equally unsettling idea: mirror matter. In this picture, the universe may possess a hidden symmetry. For every particle we know, there could exist a mirror counterpart. Same mass, same gravity, but opposite behavior under certain forces. These mirror particles would form mirror atoms, mirror stars, mirror galaxies. An entire cosmos, parallel to ours. It would obey the same fundamental laws, yet remain completely invisible. No light would cross between the two sectors. No electromagnetic signals. No chemistry shared. Only gravity would bridge the divide, gently coupling the two realities together. If such a mirror universe exists, then dark matter could be its reflection. Not a substance we lack, but a population we cannot see. Their galaxies might cluster where ours thin out. Their cosmic web might interlace with ours, offset but intertwined. Two vast structures occupying the same space, unaware of each other except through the slow mutual pull of gravity. This idea destabilizes something deep in us. We are accustomed to thinking of reality as singular, one universe, one stage, one story unfolding from beginning to end. But these theories suggest depth instead of breadth. Not a larger universe, but a layered one. Reality stacked upon itself, like pages pressed together so tightly we mistake them for one. And the unsettling part is not how strange this sounds, but how naturally it fits the evidence. Dark matter behaves as if it has mass, but no interactions, as if it exists everywhere, but belongs nowhere we can probe, as if it shapes our universe without ever participating in it. These are exactly the properties you would expect from something that is real, but not local. This is where doubt turns into astonishment. Because if another universe exists beside ours, then cosmic loneliness may be an illusion. We are not isolated in emptiness. We are embedded within a richer structure than we ever imagined. Our universe may not be a solitary island, but one shore of a deeper ocean, and yet the thought is vertiginous. What does it mean to exist next to something forever unreachable? What does it mean that the dominant mass shaping our galaxies might belong to a reality that will never know we are here? The stars we cherish, the light we study, the matter we are made of. These may be secondary features of a larger cosmic arrangement. We are not central. We are adjacent. Some theories go even further. They suggest not just one neighboring universe, but many. A stack of brains, A higher dimensional space where multiple universes coexist, each with its own laws, its own matter, its own version of existence. Gravity weaves between them, accumulating effects, distorting motion, leaving signatures that we interpret as missing mass. In such a cosmos, dark matter is not a thing. It is a conversation. A gravitational dialogue between realities that cannot otherwise speak. This idea does not solve the mystery cleanly. It deepens it. It replaces one unknown with a larger one. But it also resolves something quietly profound. It explains why dark matter is everywhere and nowhere. Why it behaves coherently on cosmic scales but vanishes in our laboratories. Why it feels less like a particle and more like a presence without form. Philosophically, this forces a reckoning. We have long equated reality with observability. If we cannot see it, measure it, or interact with it, we tend to dismiss it as speculation. But dark matter has already broken that rule. It is real precisely because of what it does, not because of what it shows. The mirror hypothesis simply takes this logic to its end. Reality may be broader than perception. Existence may not require mutual awareness. Two universes can share gravity without sharing meaning, light, or history. They can shape each other without ever meeting. This is not mysticism. It is a sober extension of physics pushed to its conceptual edge. And standing at that edge is uncomfortable, because it reframes our place in the cosmos yet again, not as observers of a complete universe, but as inhabitants of a partial one. We are not missing information because our instruments are flawed. We may be missing it because it belongs elsewhere. This does not make our universe less real. It makes it less complete. And that distinction matters. If dark matter originates from another universe, then our cosmic story is entangled with a narrative we will never read. The formation of galaxies here may depend on structures there. Our existence may be contingent on events that never occurred in our spacetime. We are shaped by neighbors we cannot acknowledge. There is something quietly humbling about this. For centuries, humanity feared that the universe was vast and empty. Then we learned it was vast and structured. Now we are confronting the possibility that it is vast, structured, and layered beyond direct comprehension. Not just bigger than us, but deeper. The universe begins to feel less like a room and more like a hall of mirrors, where every reflection hints at something solid just beyond reach. And this leads to the most unsettling reframe of all. Perhaps dark matter is not missing. Perhaps it is present, abundant, and organized, just not on our side of existence. Perhaps when we look into the night sky and feel the invisible pull holding galaxies together, we are feeling the gravity of another world brushing against ours, not colliding, not merging, simply coexisting. Dark matter may not be missing. It may be watching from the other side of existence. If another universe touches ours, even faintly, then the most profound consequence is not scientific. It is personal. It means reality is not sealed, not closed, not self-contained. The cosmos we inhabit may not be a solitary stage, but one layer of a deeper structure, influenced by forces and presences that never announce themselves. And if that is true, then isolation, cosmic or human, was always an illusion. We grow up believing we live inside a complete world. One sky, one universe, one chain of causes leading cleanly from past to future. Meaning feels local, generated by our choices, our histories, our struggles. But the idea of another universe brushing against ours destabilizes that comfort. It suggests that causality may extend beyond what we can trace, that events shaping our existence might originate outside our perceptual horizon. Not invading, not interfering, simply existing alongside. This reframes what it means to belong to the universe. We are not inhabitants of an isolated cosmos, but participants in a larger reality whose full dimensions we cannot access. Our universe may be less like a container and more like a shoreline, shaped by tides from a deeper ocean we cannot see. At first, this thought feels diminishing. If unseen universes influence ours, where does that leave us? Are we secondary, accidental, merely consequences of structures we will never know? The mind resists this, clinging to the idea that what we see must be what matters most. But that resistance fades when we look closer. Our lives are already shaped by forces we do not perceive directly. Gravity holds us to the earth without our consent. Time carries us forward regardless of belief. Consciousness itself emerges from processes we do not feel or control. We are influenced constantly by layers of reality that remain hidden beneath experience. Dark matter, in this sense, is not an anomaly. It is a mirror. It reflects a deeper truth about existence, that the most powerful influences are often invisible, that what shapes us most profoundly rarely announces itself. From the firing of neurons to the pull of galaxies, we live in side effects whose causes remain largely unseen. If another universe exists beside ours, then dark matter is not just a scientific mystery. It is a reminder, a cosmic version of something we already know intuitively, that influence does not require awareness, and connection does not require contact. This realization softens the fear. Because if we are shaped by something beyond our universe, then our story is woven into a larger tapestry. Our existence is not an isolated accident, but part of a structure vast enough to include realms forever beyond our senses. That does not erase meaning, it expands it. Meaning, then, is not something we invent in isolation. It is something that emerges at intersections between matter and gravity, between perception and reality, between what we know and what we never will. It suggests that separation itself may be relative, that realities can coexist without overlap, influence without interaction, presence without awareness. And perhaps that is not so different from how we relate to one another. Every human life is shaped by countless others we will never meet. Decisions made centuries ago ripple forward into our present. Cultural forces, evolutionary histories, and forgotten moments sculpt who we are without asking permission. We are never truly self-contained. We are always the product of hidden connections. The cosmos may work the same way. If dark matter originates beyond our universe, then our galaxies are being guided by something that does not belong to our story, yet makes our story possible. We exist because of structures that did not need us, did not anticipate us, and may never know we are here. There is humility in that. But there is also peace, because it dissolves the pressure to be central, to be complete, to be final, We do not have to be the universe's climax to matter. We can be a movement within a much longer symphony, meaningful precisely because we are not the whole. This shifts how we think about knowledge itself. Science has always advanced by revealing what lies beneath appearances, atoms beneath matter, fields beneath forces, geometry beneath space and time. Dark matter, and the possibility of other universes, extends this pattern outward. It tells us that what we observe is not wrong, just partial. That reality has depth, and we occupy only one slice of it. And that realization does not weaken truth. It strengthens it, because it invites a different kind of wisdom, not the certainty of final answers, but the calm acceptance of incompleteness. The understanding that not knowing everything does not make existence fragile. It makes it open. If another universe influences ours, then curiosity itself becomes sacred. Wonder is no longer a byproduct of ignorance, but an appropriate response to a layered reality. Questions are not failures of understanding. They are signs that reality is richer than our current frame. Dark matter becomes a metaphor here, not just for unseen mass, but for all the silent frameworks that hold our lives together. The past we don't remember. The systems we depend on without noticing. The consciousness that arises from processes we cannot feel. We are always living on scaffolding we cannot see. And yet, we live. That may be the most grounding insight of all. Even if reality is layered, even if our universe is not alone, even if forces beyond perception shape our fate, we still experience meaning, love, curiosity, fear, and hope. Those experiences are not diminished by cosmic complexity. They are amplified by it, because they occur despite it. The universe does not need to be simple for life to matter. It does not need to be fully knowable for existence to feel complete. We find significance not because we understand everything, but because we are embedded in something larger than ourselves. If dark matter connects us to another universe, then connection itself becomes the fundamental theme of existence. Not isolation, not separation, but influence without awareness. Relationship without recognition. We may never see the other side, never touch it, never confirm its nature with certainty. But we already live with that kind of mystery inside us. Consciousness looks out at the world without fully understanding its own origin. Life unfolds without ever grasping the totality of the cosmos that birthed it, and still it unfolds. So perhaps the final meaning of this idea is not destabilization, but reassurance. The reassurance that we are not as alone as we once feared. Not cosmically, not existentially, not even intellectually. We are part of a structure vast enough to include what we cannot see, and intimate enough to allow us to wonder about it. Our questions do not echo into emptiness. They resonate within a reality that is deeper than perception. And in that depth, there is room for humility, for curiosity, for calm. If another universe touches ours, then our existence is not an isolated spark in the dark, but a glow shaped by unseen hands, connected to something larger without being consumed by it. We may be less alone than we ever imagined. We began this journey not with light, but with absence, with a quiet imbalance in the motions of stars, with a feeling that something essential was missing from the story of the universe. And now, after all the theories, the searches, the widening of perspective, we end in much the same place. Dark matter remains unseen, undefined, unresolved, but the feeling has changed. What once felt like failure now feels like space. Not an error in our understanding, but a horizon for it. The universe has not refused to answer us out of cruelty or indifference. It has simply reminded us that clarity is not guaranteed and knowledge is not owed. For centuries, we believed that seeing was the same as knowing, that if something was real, it would eventually reveal itself to our eyes, our instruments, our equations. Dark matter has gently undone that assumption. It exists without permission. It shapes without speaking. It influences without appearing. And still, the universe works. Galaxies form. Stars ignite. Worlds emerge. Life becomes aware enough to ask questions that may never resolve. This, too, is part of the design. Mystery is not a flaw in reality. It is a feature of it. Perhaps the purpose of science is not to drain the universe of wonder, but to deepen it. Each discovery does not close the circle. It widens it. Each answer reveals a larger question behind it. And sometimes the most honest conclusion is not certainty, but humility. We are learning that reality may be layered, that existence may extend beyond what we can touch or test, that the visible universe could be only a surface, shaped by structures forever beyond perception. This does not make our world smaller. It makes it more profound. To live in such a universe is not to be lost. It is to be invited. Invited to wonder without demand. To accept without surrender. To understand that not knowing is not the end of the journey, but its natural state. Dark matter remains a shadow across the cosmos. But shadows do not mean emptiness. They mean depth. They mean something vast stands just beyond our sight. Dark matter may be a shadow, but shadows only exist when something greater stands in the light.